Right, I'll level another question of organic reactions. They're saying the flow chart, the flow diagram below shows how some organic compounds can be prepared from ethene. So starting with an ethene, which is unsaturated. Saturated compound A, B, and C represent different organic reactions. So these are organic reactions that are going to take place. Right, let's see. For reaction A, write down the formula or the name of the other reagent needed for reaction A. So we simply have an ethene, then it's going to come and then name of the formula of the other reagent needed. So here the formula for this is a simple addition from alkene to alkanes. So rather break a double bond or a single bond. So we'll simply need PT, which is the formula of the reagent needed, which is a catalyst there. 4.2, the type of addition reaction. So because we are producing only ethane, the name is in ethane, it means that is an addition, the regulatory is an addition. But already addition fail. Since originally this one and this one, double bond and then hydrogen, then hydrogen here and hydrogen here. So we must add only the hydrogens, which is H bonded to H, so that it can be an ethane. Otherwise, it's going to be with some other groups. So we must only add this one, only hydrogens, then will be hydrogenation. Be careful, Barley. The type of addition. Now we're given as an addition reaction, but what type of addition? We check out by ethane, then delete this one so that we can have only a pure hydrocarbon, which is this one. So that's why we have an ethane. The formula or the name of the catalyst used. So the name of the formula of the catalyst used, that's why we have a platinum PT. So what was the first one? The formula or the name of the other reagent for reaction A. So I don't know. So platinum. It's fine. The reagent that is needed or the condition there, it means there must be no water, but let's just write the other reagent that is needed. It's fine. One use of a reaction in the food industry. One use of the reaction in the food industry. How do you use the reaction? How is the reaction used? The hydrogenation. So I think because we are moving from unsaturated to saturated. So the food that is making from this, I think it will be production, a production of margarine, production of margarine. Then that's what we have. Right, for reaction B takes place when ethene reacts with hydrogen bromide. So the first one, it means the correct one, they say the name of the formula of the another reagent, which means they're saying other reactant. We used to say reactant, then is not a reaction condition. So another reactant, it means it must be H2, the formula, or the hydrogen gas. That will be the name. Then that's why they want a catalyst here. which is electron. Right. Then reaction B takes place, it reacts with hydrogen bromide. So what is hydrogen bromide? Is hydrogen reacted to Br. Then that's what we have here for this reaction, right? Which is O, is written here, HBr. For this reaction, write down the name of the reaction that takes place. So moving from B, unsaturated compound B, it is reacting with this one. So of course, the name of the reaction that takes place, a simple way, we're moving from alkene, then compound P, always when we move from alkene, we're going to do what we call an addition. That will be addition reaction, because we're going to add halogenation. Balanced equation using the structural formulae. Now let's do it. We're going to have this one, double bond, then hydrogen bonded to hydrogen, hydrogen, another hydrogen here, plus, now they said it reacts with H bonded to Br. Now they produce, namely, let's have carbon and another carbon. But what is going to happen here? This double bond will break to this carbon and this carbon. And then now, what is left? It means Br must be fitted into this one. Br or H. In this case, the number of hydrogens were equal, so there is no need of Markov-Nikov. So we just have our hydrogen here, our hydrogen here, our hydrogen here, and our hydrogen here. There were two, so there is no need of Markov-Nikov. Then this is what we have. Then it's a balanced reaction. So 4 marks for that. Name of the name of the homologous series to which compound B belongs. The homologous series, or the type, or they're saying the type of the product, the compound P. Compound P is this one. So it is a halo from the group halo, and then alkanes. This is a single A. Haloalkanes, why? Because it consists of hydrogen, bromine, which is halogen, and the other single bond between carbon atoms, which is an alkane. So it's haloalkanes. Now let's move on. Consider reaction C. Reaction C, they are saying ethene is a monomer. Ethene is a monomer of compound Q. Explain clearly what this statement means. So this reaction, they are saying this one is a monomer of this one. So what do you mean by a monomer? The statement means ethene, saying, reaction C is an example of, ethene is a monomer of compound Q. Explain clearly what this statement means. This means that compound Q is having compound Q has lots of ethene bonded together to form a polymer. That's what we can say. compound Q has lots of this ethene, bonded together to form a polymer. That reaction C is an example of polymerization reaction. Name the type of polymerization reaction. Which reaction C is an example? Normally here our addition polymer will take place here because we add, that's why I say lots of ethene bonded together. So you should add more ethene together. So that will be an addition polymer. Write down the structural formulae of the polymer Q, indicating only 2 repeating units of the polymer Q. Okay, 2 repeating units. Polymer, so okay, 2 repeating, that is will be 1, 2. That is used to make a polymer. Then we must have another 2 joined together. Now we have these ones, which are our hydrogens. But if you can check, hydrogen carbon show that one bond lower show one bond to join another monomers to come to this one. So we're going to have a bond here. But the question is the structural formula of polymer Q. So when say polymer, now these bonds are waiting to join another ethene that will come here. So meaning if we have an ethene like this, the hydrogens here, now for us to join it here, then we must break this bond, then it will come here, and then we have many of them, the other one come this side, and then the structure will keep on being big and big and big and big. So rather we can leave it here, or because it's a polymer, of course we can do like this to show that there are more joints that we can make on the structure. So but the inside one, that will be 2 repeating. One, why always say 2 repeating, means we are counting, this is the coming from the first monomer and the second monomer, and then but because they said consisting of 2 repeating only, then we're going to have only this structure here. But to show that it's a polymer, then you put the bracket and down. So that is 50 marks from this paper. So just comment if there's any question or any correction on the video or any addition on the video, so that we can learn more. And don't forget to subscribe and share the video.